Welcome to Lecture 3 in Introduction to Applied Internet of Things. This is Programming Part 3. In this part we will talk about loops and lists mainly. Iteration, we have used it already. We have used the while loop, and the while loop uses a condition and run its block of code as long as the condition is true. By write while true, we create an infinite loop that runs until we turn Pico off, or we use a break command. And that's quite common that we want to use an infinite loop in Pico, because we want to run the program forever until we turn it off. In this example, we use a condition n is less than 10. And here in this example, we will use the print command to print out n. That should be 0, then 1, 2, 3, up to 9. 10 is not included. Since 10 is not less than 10, it's equal to 10. Another important thing in this lecture is the lists. List is a collection of values. Like a value could be a number, it could be a string, or in this first example I will use a pin like a value, and then I use 3 different pins to control different LED lights. Lists are sequential. That means that every item stays in a specific order. So if we look up in the right, you can see the value 1337. You can see down in the creating my list here is using square brackets, and then you write 1337, and the values are 1337, but the index starts with 0, 1, 2, 3. So if we want to read values, for example, the first value is equal to my list, then you use the square brackets 0. That means the first value, that should be a 1. The third value is 2, so you write my list square brackets 2 and get in this case a 3. And the fourth value is 7, and it's located on index 3. You can also remove items, you can add or append items, or you can change items. Together with lists, we often use for loops. For loops is a repeating, just like while loops, but for loops are sequential. They go through items one by one. While loop checks a condition, but in both cases they avoid you to avoid repetition in your code. For example, if we have 3 LED, we can use 3 different pins and program one by one, but instead of using loops, we don't have to repeat that much. You can use a break command, or you can use a continue command to break loop or skip one turn. But in this second example, we use the range format. The range is a collection, sequential. So if you write range parenthesis 5, you get 0, 1, 2, 3, and 4. You get 5 values from 0 to 5 minus 1, like that's 4, because 5 is not included. If you, instead of just write 5, write 1 and then 5, you get start with 1 and get up to 5. 5 is still not included. If you have 3 values, like 2, 11, and 2, we start with 2 and step 2 up to 10, because 11 is not included. You can also step backwards. Then you start with, for example, 10 and go to 0. 0 is not included, and go minus 1 step every time. In this first example, we will use another for loop, often called for each. And in the second example, we will use this range. We will connect 3 different LIDs and use the short leg, the negative, on a rail that we connect to the ground using a resistor. And the positive sides are connected with 3 different pins, in this case 10, 13 and 15. And we will program each one using a loop. First of all, we have to import some things. I will import the pin and I will import sleep. Then I will create my list. I call it my list, my LED. And using the square brackets. And I will use separate lines. The first one I will use a pin. And I said it was 10. And set it on pin out. And then comma. And then pin 13. Pin out. Comma. Pin 15. Pin out. You can use this one line for this, but I will use multiple lines. It's easier to see what's happened. And then I will use a while true. So we will run this program until we turn it off. Now I will use the for each loop, and I use for LED in my LEDs colon, and then use the LED dot on, turn one LED at a time on, then I sleep for a short period, sleep for like 1/5 of a second, and then I turn it off. And in this case, the first time it will use the first one, the 10, and then when this is done, it go back and turn 13, the second one, on, and then after a while it turns the number 15. And when I turn the program on, you see that we control one of each of these lights here. And if I, for example, increase the time, like 2 seconds, and rerun the program, you see it just goes slower and slower. But this will continue, because when this for loop, it will run 3 times. And when it's done, it will continue, because it's inside a while true loop that continue forever. In this case, I said we used a for each loop, and in most cases that you don't need an index for the iteration, I think the for each is a simpler way to do it. It just calls something. In this case, I said for LED, and the LED then is a variable that is one of each of this at a time, and can turn it on and off. And the next LED is the 13, and so on. But in this case, this LED is just inside this loop here, so I don't use it outside. But in most cases this is fine, but sometimes you want to know in what place, if for example if you don't want to remove something from the list or stuff like that. So in next case we'll use the other way with a range instead, and show that one. And in this case we will use a NeoPixel strip with 1, 2, 3, 7 different LEDs with different colors. And this one has 3 connections, one for ground, one for data, and one for power. And I use a capacitor between the power and the ground, and in this case it's turned the wrong way, because the long leg should be against this red one and the short leg should be against the ground. Also we use a resistor to control between the data line and the pin. In this case I will use pin 15 to control this one. How does this, I will show this setup first. You can see here is the LED strip, and in this case you can connect another one up here, but I just use 8 ones here, and you can see all the things here. Hopefully, wait. Here you have the data line, and I use a resistor to connect to the one in the center, and the red wire is connected from the power here to, in this case, up here. And I use this ground, and you can use any ground, and you use this capacitor between the power and the ground to make the power more even, and it will work better. A NeoPixel, in each of one of these pixels there are 3 different colors. It's a green one and a red one and a blue, and often you say RGB, that means red, green and blue, and you get different colors by mixing these ones. If you turn every one of those to full, you get white in this case, and if you turn every one off, you get black. Each color have a value, and it could be from 0 to 255, and the higher the value, the stronger the color are. So for example, if you have 25500, that means full red, 0 green and 0 blue. That means it will you can see a red light. RGB is different from normal paint. Then you paint, you mix light instead, and adding more will make it darker, but in RGB you will add more, you make it brighter instead. So we will control these ones, NeoPixel strings, using a NeoPixel library. So first we import pin, sleep, and from a new library called NeoPixel we import NeoPixel with capital N and P. I imported like this from NeoPixel, import NeoPixel, because I think the code look more nice, but you can do whatever you want. And now we will start the coding. First of all, I will have a variable called number of pixels and set it to 8, because in this case this strip have 8 different pixels here. But if I swap this one or add another one, I want to change this to, for example, 16, but I don't want to change in multiple places in my code, so I save a variable here and call it number of pixels. Could be capital letters as well. And then I will have a data pin. I call it pin, and use the pin 15 because I connected this here. This is pin 15 to the data here in the middle here with using a resistor. And now I use the NeoPixel. I call it like this and write NeoPixel and then I use this pin and how many pixels, number of pixels. Now we are ready to start the program. While true, that means we will run this program forever, and I will turn it like this so that we later on can see the program. Later on. So first I will turn every pixel to red and using a for loop. For E in range. Now I will use number of pixels. So in this case I will get first, it will be get 0, then 1, 2, 3, 4, 5, 6, 7, then it runs out because 8 is not included. And these are the indexes for the pixels. 0 is the first one and 7 is the last one. Then I use this NP because that's a list, and so in first run it will get the first one, in the second iteration it will get first 1 and in the third it get 2 and so on. And I can just tell a value. So if I want red, I write 255, that's full red, and 0 green and 0 blue. Then I use the command np write to change it, and then I sleep for a short period, half a second. Now I turn each and one of those on, and after a while I copy this one. I will turn them off. So instead of red, I change it to 0. So each one of these will turn off. And now we will test the program. And here I started the program, and I will change this, and you see that now we are on the second for loop, and now we are on the first one. Then we turn them on to red, and then we turn them off one by one. So this is a simple program that controls multiple LEDs, in this case a NeoPixel. If you want, you can add another color. So once more I copy this one, and in between this one I will turn them to green. So first, my first loop will turn them all to red, then I will turn them all to green, and then all to turn them off. And now you see here they are all green, and now you see they turn green and then turn off. And by different sleep you can get this animation faster or slower if you want. So this is how to control things using loops and lists, and in a lot of cases it's really handy to do this. Good luck with your programming.